Hey, what's up, everybody? It's Saim Safdar, and you are listening to the cloudnative.fm podcast, hosted by Cloudnative Islamabad. And I'm thrilled and excited to host this show for you. This is the episode number 2 of cloudnative.fm podcast, and today is February the 23rd, 2021, and I am fortunate enough to surround by the world-renowned Docker and Kubernetes author Nigel Poulton. Today, with the help of Nigel, I am able to understand how you can make your Kubernetes and cloud native journey less scary and more exciting with my guest, Nigel Poulton.
Thank you everyone for joining our session today, and I'm really excited for being following along Nigel Poulton for a very long time, and hopefully I'm able to understand these words about how I can make your Kubernetes journey less scary and more exciting with my guest Nigel Poulton. And I think you don't need any introduction if you are background from Kubernetes or Docker or a DevOps kind of or service mesh. If you have been into the DockerCon and KubeCon, you know who's Nigel is. And if you doesn't know already, so Nigel, over to you. You introduce yourself a bit.
Yeah, so I know, by the way, thanks, Saim. So I feel a lot of pressure now. No, so I live in the UK, and I worked with Docker since before the 1.0 release. I worked on 0.9 a lot, but even a little bit before then. So quite a lot of years working with Docker and containers. I am a Docker captain, and I've been a Docker captain for a long time. And I've been working with Kubernetes and other cloud native stuff for ages. I should really know this, and I don't, but I think something like probably more than 8 years I've been working with this kind of stuff now, which to me seems a little bit crazy because it almost seems like some of this stuff can't be 8 years old, but actually some of it is. So yeah, that's me, based in the UK, and I'm addicted to cloud native and containers and Kubernetes and that stuff.
Thanks, Nigel, for your introduction. And I am addicted to your content as well that you're putting on in the form of videos and books and all of that stuff. So I'm really kind of interesting to know when you're not talking about Kubernetes and cloud native and Docker. So how you spend your time?
When I'm not talking about any of that stuff, the only time that I'm not talking about that stuff is when I'm asleep at night. No, I do like football, soccer. I kind of like cars, and I've got 3 daughters and a wife that take up quite a bit of time as well. So I do balance my life across like work and family, and then football and cars. But I really, really do like the technologies that I work with. So it's almost like my work stuff is more of a hobby than it is work. And I think as we have the conversation, Saim, that some of this stuff is like, if you like technology, this is really cool stuff. It's not like boring, dry stuff. This is like cutting edge. It's interesting. It's fun. And it's pretty cool from a tech perspective.
Yes, I really love those technologies that scares me for a shorter time. And then I learned that no, it's not a more kind of starting, it's the exciting technology. So I kind to know which stream you are just putting on in that if you are joining EPL from side, because I am a Liverpool guy.
Ooh. Yeah, so I support a team called Sunderland, who used to be in the Premier League, but got relegated down one league and then relegated down another league. So we're in the 3rd league now. If I have a Premier League team, like my team that I grew up with is Sunderland, and that's who I love. But my middle daughter supports Manchester City, and she plays a lot of football. So I do watch a lot of Manchester City as well. But do you know what? I probably watch almost all of the football that's on the TV here in the UK. Like, you know, there's 4 games on a Saturday and 4 games on a Sunday and a Monday game. So I watch them all. So, yeah.
Okay, so I am a Liverpool guy, and I'm really happy that last time we won the Premier League for
Yep, congratulations.
Thanks, Nigel. And we're excited about for this thing. So let's jump again for the first basic question from.
Sam, can I just say one thing first? Can I also give a shout out to the England cricket team for winning the 2019 World Cup?
Yes, and many of the players that are already here in Pakistan because PSL is.
That's right.
And I'm supporting a team where Alex Hales is playing.
Cool.
So thank you, Nigel. So let's give us the very first question for you. What container are and what the Docker is?
Yeah, so normally to answer this question, what is a container? I'll wind the clock back to virtual machines. So if you try and think about life before VMware, if you're old enough to remember that, yeah, we used to build one application on a physical server, and it was really, really wasteful. Like developers, it's the same today, right? Developers don't usually know how powerful they need the infrastructure for their applications to be. So, you know, before virtual machines came along, we would have an application, and in operations, we'd say to a developer, how fast or how big does the server need to be? And the developer was like, I don't know. So in operations, we would just buy a really big, powerful server, install the application on it, and the application would use like, I don't know, like sometimes 5% of the server, like really wasted it. But we couldn't then really install more than one application on a server. It didn't work. Then along came VMware with virtualization. Now, look, I understand that virtualization's been around for a long time, even back to technologies like the mainframe. But VMware made modern virtualization like we know it today. And that came along and it said, well, we'll take a physical server with all of these unused or wasted resources, and we'll let you install multiple applications on a physical server. And what we'll do is we will, and I know that a lot of you will already know this, I'll get to why it's important with containers in a second, but you would take a physical server and you would slice it up into virtual servers. And every one of those virtual servers, yes, it's a software construct, but it looks and it feels and it smells as if it's a real physical server. Like the application doesn't know, just thinks it's got a server, right? So that came along and it made us get really efficient with our hardware. We could really ramp up the utilization of our hardware, 10, 20 applications per physical server. And it meant that we could deploy applications faster because we didn't have to talk to the finance department and get a purchase order approved and ask HPE or Dell or Cisco or somebody to deliver us a server and then rack it in the data center. We didn't do that anymore, just a virtual machine, spin it up, and you run your application. And it was great. Now, containers do a very similar thing to a virtual machine, but virtual machine virtualizes a physical server. So every virtual machine has virtual CPU, virtual memory, virtual disks. Containers virtualize an operating system. So kind of if you got your physical servers here, and then you layer your operating system higher up the stack, containers do virtualization at the operating system level. So instead of having a virtual CPU, it will have a virtual process ID table. Instead of having a virtual disk, it will have its own virtual root file system. And instead of a virtual NIC, it will have a virtual Ethernet 0 interface. So it's kind of like virtual machines, but it virtualizes the operating system. So every container is actually a virtual operating system, but to the application doesn't know it's a container. The application just thinks it's got a normal operating system. Just like an application in the virtualization world thought it had a real server, applications on containers think they've just got a real operating system. Now, the power of the containers or virtual operating systems over virtual machines is that every time you spin up a virtual machine, let's say you've got one physical server and you put 10 virtual machines on it, that means you've got to put 10 copies of Windows or 10 copies of Linux. And we know that every operating system, just for the operating system to run, so this is before we install an application, every operating system needs its own CPU, needs its own memory, needs its own disk space. So if you install 10 virtual machines and 10 operating systems, every operating system is stealing loads of CPU and memory and stuff. In the container world, and this is hard to conceptualize without diagrams and things like that, but because you're virtualizing an operating system, there is only one operating system that gets sliced up. So you don't have 10 operating systems, each one stealing CPU cycles and each one stealing memory. There's just one, you carve it up and you install applications into those virtual operating systems. And we call those virtual operating systems containers. Now, Docker, so the thing is, right, like being able to do containers, Google has been doing it for years and years and years, like probably before some of us were born, okay? It was running search and it was running Gmail and all kinds of applications on containers, but it was really hard to do those containers. Like you almost had to be a kernel engineer to be able to do it. And what Docker did was they came along and they made it easy for people like you and me, Saim, to be able to say, we can build containers and run applications in containers. Now, Docker came along and made it easy for everybody else to do it. Because like the technologies to do containers have been in the Linux kernel for a long time. They were just like too hard for most of us to use. Docker came along, made it super easy.
Really interesting. So it's kind of, just what the containers are, how it's different from VM. But I want to know how Docker is become very successful in achieving that technology and becoming a thing for us that for the previous time wasn't able to do that with a lack of some kernel engineers, a lack of support. It's a very hard thing. But how Docker even came to know how Docker made it very simple for us.
Yeah. So Docker, if you wind the clock back there, right, was originally a company called .cloud. And they were, I forget the details now, but they were doing like a sort of application SaaS service on top of Amazon Web Services. And they wanted to obviously be as efficient as possible so that they could use as little Amazon hardware as possible, yeah, to keep their costs down. So instead of going virtual machines, they invested a lot of engineering effort into working out how to build containers. And they built their SaaS service on top of containers because it was more efficient for them. Now, when they did that, they kind of needed a tool in-house that made it easy for them to build containers and run applications in containers. And that in-house tool that they built eventually became Docker. So what happened was .cloud, like I said, they started using containers internally to present a service to developers. That service wasn't very successful and the business was struggling. So they said, I tell you what, we've got this really cool in-house technology that could revolutionize the world. Let's make it open source and build the company around that. So .cloud basically changed its name to Docker Inc., totally changed what it did. Instead of being a SaaS service, it became the container company. And it just went from there, developing the Docker tool set that made working with containers super simple. And the thing is, right, like I don't know about you, but or if anybody that's watching or listening, but me, when I first learned about VMware and virtual machines, my mind was blown, like my head almost exploded. I was like, this is so right and so simple. Why haven't we always been doing this? It was just like one of those moments where you're like, this just makes so much sense. Now, when I first looked at Docker and containers, for me, it was the same as when I saw virtual machines. I was like, it makes so much sense again. And I think that a lot of people and a lot of companies have seen that containers take what we did with virtual machines, but they do it more efficiently. So you can spin up a container faster than a virtual machine. It's more lightweight than a virtual machine. So you can have more applications per physical server with containers than you can with virtual machines. So I think the industry looked at that and said, you know what? Containers is the next logical step, and Docker make it really easy for us, and thus it became a success at the time.
Yeah. So when I first introduced the Docker, so next thing came up in my mind, what after that for Docker? So I think that's managing a one container is one thing, and managing a millions of containers in another things. So how to manage all of these things? So I got to introduce to Kubernetes because of your great course, Kubernetes deep dive at the A Cloud Guru, and I got to introduce myself from there. So what Kubernetes is and how it's managing the whole life cycle of containers so easily.
Sure. So I'll stick with Docker first because that will lead us into Kubernetes. So Docker gave us this great tool to build and manage containers. But what happened was, I think like you've just suggested there, Saim, it's great if you're on your laptop and you've got a couple of applications and you're playing around. But when you get into the real world and you start wanting to use this in like production in the, you know, with real applications, suddenly it grows huge. And then you need a tool to manage that. So this like sprawl of containers, we needed help managing it. Excuse me. So Docker Inc. were like, well, tell you what, we will develop a tool that they called Docker Swarm that will help you manage applications that are running on Docker, on containers. So Docker Swarm came along at about the same time, around about 2014, when Kubernetes came out as well. So they both came out to help us manage lots of containerized applications. Now, the history behind Kubernetes is a little bit different. So Kubernetes came from Google. So like we said before, Google were running search. So every time you would do a Google search, in the background, it would spin up a container, do the search, give you the results, kill the container. So Google was going through like famously billions of containers a week, and it needed its own internal technologies to help it manage its own containers, because it was using containers for other things other than just search and stuff like that. So they have a couple of in-house technologies called Borg and another one called Omega that help them schedule and manage containers. But the teams of people that worked on these technologies they also saw what was going on in the industry with Docker and containers and said, why don't we take all of the things that we've learned internally at Google using containers for years, and why don't we build an open source product based on our expertise that will help people work with containers? And that's how Kubernetes came out. So Kubernetes, it's not an open source version of Borg or Omega, but the Google people that built the first versions of Kubernetes took everything that they learned from using Borg and Omega internally, and it used that to help them build Kubernetes. So Kubernetes and Docker Swarm for a while, probably around about 2016, 2017, were kind of rivals as to which technology will be the one that the community and the market will choose to be like the de facto, if that worked, technology going forward. Now, Kubernetes won that war. Don't get me wrong, Docker Swarm is still around, and it's great if you are a small business and you haven't got the engineering resources to learn Kubernetes. But for most people going forward, Kubernetes will be the right technology to deploy to help you manage all of your applications that are running in containers. Does that make sense?
Yes, definitely. Now, just a really interesting story for me because the two companies having their own project that they are working on, and they decided now why not that giving to the community and what we are learning and what we are achieving from these tools, why not rest of the people are achieving from that. But really quite a very interesting points because from the very 3-4 years from 2015 to 2020, everyone starting from Docker and eventually came into the Docker Kubernetes. But eventually we see a broken relationship between Docker and Kubernetes in the version 1.20. So do you want to clarify what this is?
Yeah. Yeah, it's a really good point actually, because it did cause a lot of confusion. So I think the first things to say are that Docker is still a very important and very popular tool, and so is Kubernetes. But it's almost worth thinking of the way that most people use them, okay, is they use Docker as a development and a build time tool, and then Kubernetes as a production runtime tool. So what a typical workflow for an application will look like is a developer will write an application in whatever language he or she likes, okay? Doesn't matter. Choose your favorite language, okay? Then you will use Docker. There are other tools as well, but it's common to use Docker to build that application and its dependencies into a container image, okay? And then that container image runs in production on Kubernetes. Now, that is still going to be the case going forward. It's still going to be a common pattern to write your software and build it into a container image using Docker. Only in the past, you then would run it in production on Docker as well, or on Kubernetes. Now, you will just most of the time run it on Kubernetes in production. But it gets a little bit complicated, right? Because Kubernetes is kind of a higher level tool. So Kubernetes actually doesn't know how to start and stop containers. It needs a technology called a container runtime to do that. So if you've got a Kubernetes cluster, and let's say there's 20 machines in it or 20 nodes in your Kubernetes cluster, those 20 nodes can all run containers or containerized applications. And Kubernetes sits above those nodes and it makes decisions like which node should run this container and which node should run that container. And if a node fails, where do we restart those containers? Kubernetes makes those high-level decisions. But the low-level decisions on like actually starting the container and running it, Kubernetes used to use Docker to do that. So every Kubernetes cluster node would also run Docker to start and stop containers. I'll go into a little bit of detail, but not too much. Kubernetes, over the years, decided to make that container runtime layer pluggable. So it has this layer called the container runtime interface, the CRI, which is pluggable. And for the longest time, it was just using Docker, but Docker doesn't support the CRI, so it needs a shim. And it's a little bit of an ugly solution. So what they said in Kubernetes 1.20 in December 2020 was that we're deprecating Docker as a container runtime, okay? So in a future release, and we don't know which release, right? Maybe 1.23 or something, Docker will no longer work as a runtime. But those images that you've built, they will still work on Kubernetes, okay? And instead of using Docker as the container runtime, you'll use containerd or cryo, or there's lots of different, because that layer is pluggable now, that container runtime can be anything. But the thing is, these container runtimes all work with standardized container images, and Docker builds standardized container images. So you can continue to build your apps and your containers with Docker. You just won't use Docker on Kubernetes to run them anymore. So I'm learning, Saim, right, that this is kind of hard to explain without a bunch of slides.
Yes, definitely. But
the thing is, think of the container, if you know VMware, right? Think of the container runtime almost as being ESXi, and then Kubernetes almost being like vCenter or something. I mean, I'm not even up to date on VMware anymore, but Kubernetes is much higher level and it uses another tool to actually start and stop containers. It used to run Docker, still does, but in a future version, it will stop using Docker and it'll start using something else, but that something else still works with Docker container images.
Yes, definitely.
I hope that makes sense.
So actually, in the past, it's a quite interesting story. Everybody listening to us, so how these technology evolves, how they emerges. So quite interesting for me because in the Kubernetes repo, the code level, they have inserted a whole code of the Docker. So they think it's quite difficult to manage because these two are separate projects. They have separate dependency and separate life cycle. So I got to know this thing that Docker is an entire stack rather than just a container runtime. And suddenly, when this change happening, now we think that Docker is not just a container runtime. It's building the images, is an entire management lifecycle for a developer. So can you put on more detail about this
Yeah,
style stack?
sure. So I think what happened, and this is normal, right? And it happens all the time. But Docker came out and it was a good tool for runtime, right? And it added in build, the ability to build images and things. And so what happens is you have a tool that does something, but there are other pieces that need to get you somewhere. And Docker came along and said, we want to make life for developers really easy. How do we make life easy? Well, we make taking your code, building it into an image, and then running it, we'll make that as easy as possible, okay? And they did a great job of that. Build the image, run the container. And then it was like, oh, okay, what about applications that are more than just one microservice, so more than just one container? You might have a web front end, and I'll be simple, right, and a database back end. How do we run multi-container apps? So then they were like, right, they acquired a company called Orchard, I think, that became Docker Compose. And that got sort of brought into the stack. And then it was like, that's kind of okay, but it doesn't help us on the runtime side of things, restarting failed applications and things like that. So then they built Docker Swarm. And over time, it became this bigger, like, whole stack that you said that did make life easy, but it became a little bit bloated. And at the same time, Kubernetes is coming along, and Kubernetes is like, right, we don't actually want to know about how to run the containers. Well, let something else do that. We want to do the higher level stuff. And the natural choice was, well, we'll use Docker to do this, the runtime of containers, because everybody knows Docker. It's kind of the industry standard, and it was fine. But then as Docker started doing more and more and more, Kubernetes was like, well, Docker's doing stuff that we do already, and there's overlap, and it's too bloated for us. We don't really need all of that now. What we need is we just need the runtime. Now, at about the same time, Docker was like, do you know what? The Docker stack has become a bit of a monolith. So we'll start breaking things out. The developer experience will stay the same, but like the low-level code, the plumbing, will start breaking features out and developing them on their own. They'll still talk to each other. So what happened was Docker, so even Docker itself said, we're going to break out the runtime. So Docker broke out the runtime, like that low-level start and stop container stuff, yeah, into a technology called Containerd. So if you run Docker today, it's actually a tool called Containerd and runs, we don't want to get too complicated, right? Let's just go with Containerd that runs your containers. And all Containerd cares about, starting and stopping containers, is pretty much it, just for our high-level conversation, right? And it donated that as open source to the CNCF, the Cloud Native Computing Foundation. And Kubernetes was like, well, actually, that's what we want. So what you will find is that instead of running, I'll call it full-fat Docker, like the whole stack, the easiest way to get rid of that in Kubernetes is to replace it just with Containerd, because Containerd has already been taken out of Docker. It does just what Kubernetes wants. So most Kubernetes clusters, in fact, I saw I think it was a StackRock's report or somebody's report just a month ago, was showing that I think in the last year among their customers, Docker as the container runtime in Kubernetes environments had dropped something like 75% to 50%, and Containerd had gone up from about 12% to about 33%. So we're already starting to see people move away from using Docker, full-fat, full-stack Docker in Kubernetes, and replacing it with like the slimline Docker that's called Containerd. And I mean, that's what I've been doing on certainly my GKE clusters, my Kubernetes clusters on the Google Cloud. For a long time now, I've been ticking the option that says, run me Containerd instead of Docker.
Yes,
Does that
yes, definitely. I think when your report is asking, it's a report from SysDig that they are asking.
right? Yes.
So is that Containerd is now more of the thing right now. But I think
Yeah.
hats off to the Docker that it doesn't feel about from the project. They donated to the Containerd as their component to the CNCF. So separate entity is maintaining that and all kind of things. but reminding us that when you are building container before in the Docker, there is so much happening behind the scenes that you didn't even bother about. So as the Docker, so the next question is for the people's pop of mind. That Docker Swarm is donated to Kubernetes, but ever since we doesn't see some kind of updates and some kind of things from Kubernetes on Docker Swarm. So people like to know that they can run Docker Swarm in Kubernetes for small scenarios, like because Docker Swarm is really extensible for and really fast for smaller components, smaller app, and it's going to be a very good tools for smaller apps, and it's really easier for people to understand as compared to Kubernetes.
Yeah, so I 100% agree with that. Like Kubernetes is great and it's got a really strong future, don't get me wrong, but it's really quite complex and hard, especially for smaller organizations. Now it is getting easier and the community are working hard to make it easier. It's improving, but I really don't feel like it's for everybody at the moment. And if you are smaller, Docker Swarm is an amazing technology. It has a strong future still at Mirantis, so they've committed to it. I know they're working on bringing things like the container storage interface to Docker Swarm. Things that have mainly been Kubernetes so far are starting to be brought into Swarm as well. And they are I forget what their latest commitment was, but I know they had committed to a future for Docker Swarm. So if you're smaller and you need something easier and that is still pretty slick, Docker Swarm is still a great tool.
Yes, it's a tremendous tool. I've done a lot of stuff in Docker Swarm, and every time I do that, I really appreciated how simpler it is. So next question, we'll start it from Docker to Docker Swarm to Kubernetes. So next things people got in mind, what after that? And for after that, we see some service mesh thing that's coming up. And can you introduce this stuff, what service mesh is? And number two question is why there are so many?
Oh, yeah. So I think the idea of a service mesh, for me, right, it's to add or to augment your Kubernetes environment. And don't get me wrong, service meshes do more than just Kubernetes, okay? But to augment your environment from a network perspective, I think, okay? So service meshes tend to bring things like automatic MTLS and encryption of traffic between your containers or between your applications. We'll talk about it in a little bit detail more in a second, maybe, but also like network telemetry to expose what's going on in your network, and also to implement more advanced networking features. So the thing is, right, a dead simple one I always think is encryption. So you want ideally all of the traffic between your applications. So whenever they're talking to each other via their APIs and what have you, really we want it to be encrypted. Now, what we don't want to do is we don't want to go and say to all of our application developers, can you start encrypting your traffic, please? Because they'll all do it a different way and it'll be a mess. And application developers, to be honest, from like a business perspective, they should be working on more customer facing features and things like that, and not worrying about infrastructure level things like securing or encrypting traffic. So what a service mesh will do is if you deploy a service mesh to your Kubernetes environment, just in case people do know a little bit about Kubernetes, okay, I will go into a little bit of detail, but not a lot. So you will run your containerized applications in a Kubernetes pod, okay? And if you've got like a front end and a back end, again, you'll have at least 2 pods, but probably multiple of them, right, for scaling. What a service mesh comes along and does is it injects what we call a sidecar container into all of those pods. And that sidecar container basically sits in between your application container and the network. Now, the beauty of it is the developer doesn't even have to know. In fact, the application doesn't even have to know that that sidecar is there. All your application sees is network traffic coming in, network traffic going out. And the sidecar service mesh container intercepts all of that network traffic. So traffic going out, it will encrypt. The application doesn't even know it's happening. and then traffic coming back in, it decrypts, passes it on to the application. And you know what? The application doesn't care, but we have suddenly secured our Kubernetes network or our application network. And the same for, the telemetry and the advanced networking and stuff like that. It brings advanced infrastructure features and capabilities and insights into what is going in your topology. Almost like picking it off a shelf and just getting it there without having to build it yourself or without having to get your application developers to even think about it. That's the beauty of a service mesh. And I think for anybody that's serious about going into production with Kubernetes now, like if you're already in production and stuff and you don't have a service mesh, for sure start to look at retrofitting one. But if you haven't gone to production yet, you should be putting a service mesh, in my opinion, like very high on the agenda of things to get right before you go live into production, because it can bring so much. Can I want to say something as well that's not service mesh related, because when you talked about, we've gone from Docker to Swarm and to Kubernetes and what have you. I also do think that the future for Kubernetes, and this might be quite a few years away, okay, but I think we need to get to the level where Kubernetes is just seamless and it's almost embedded just there. Kind of like, when you deploy an application to Windows or Linux, like lots of years ago, we had to be experts at Linux to run an application on Linux. You'd have to be able to make and, compile your own kernels and things. Whereas now Linux is so simple, we just deploy the application to it and it works. I feel like at the moment we're at the stage where we need to be, we do need to be experts at Kubernetes. But I think in the future, we will still need Kubernetes experts, of course, for when things don't work. But I think for day to day, you won't need to be a Kubernetes expert. It will just work so well. It'll be in the background. You'll almost forget that it's there. And it'll just be like, we're deploying our applications. Oh yeah, it's Kubernetes is managing it all, but it just does it. Do you know what I mean with that?
Yes, definitely. And the question around the service mesh is a really hot topic when you do a dark large deployment or a canary rollout and you have some circuit breaking pattern things. The service mesh is a go-to tool for you. But
I think, yeah.
Go on. It's a next question. It's a really exciting question, because service meshes are so many. It's going to be a really scary for the people. That's istio, linkerd, console, Kong, Kuma, Aspen mesh, and so many of them. And what happened to the istio is going to the open usage common rather than going to this cloud data computing foundation. It's a relative very confusing term. So I think you are the right person who figured it out to us what happened there.
So I think, well, we already talked about Docker Swarm versus Kubernetes. And at the same time, there was Mesosphere, DCOS, and some other tools out there that kind of competed. And that tends to happen across technology all the time. The problem for consumers or for users is that it creates like uncertainty, doesn't it? You don't know you don't want to choose the wrong one and then have to change later, do you? And that's the big problem with the service mesh space at the moment, is that I don't really think we know who the winners and the losers are going to be. Now, a tricky one, right, is that, so the CNCF so it has this whole process where it adopts projects, nurtures them through until they're mature, provides governance and things like that. And then they go on to graduate the CNCF and be like production grade products. Kubernetes is the flagship one there. That was a CNCF project, and it graduated years ago now, and it's super popular. And there's a lot more out there. However, linkerd and others on CNCF service mesh projects. And you would almost think that makes them almost guaranteed to be a success in the future. But the thing is, istio is by far the most popular service mesh at the moment, and it's not a CNCF project. And Google, who owns istio effectively, doesn't want to donate it to the CNCF as a foundation. And I think, okay, this gets a little bit political. I'm not on the inside, but it's just my opinion, okay? So I have to wind the clock back a little bit for this. Kubernetes came out of Google, and it's fully open source, and everybody's using it. And arguably, I'm not saying this is the case, but you could make an argument for this, that other companies are being more successful with Kubernetes than Google are. Now, I think the technology people at Google, they just want to build great technology, right? But Google is a company that needs to make a profit and all of that stuff. It has business managers and everything like that. In fact, it loses a lot of money on its cloud platform. I mean, a lot of money every year at the moment. So I just think that it's got istio and it wants to kind of keep a bit of control over it to see how it can monetize it in the future, without, I think they're just worried that if they make it fully open source to a foundation like the CNCF, that other people will use it almost against them. I hope I'm making sense when I say this, and that they just seem like they don't want to share it like they did Kubernetes. And I don't mean anything in a bad way to anybody at Google when I say this, because of course Google has to make money. All companies do. And I'm sure that the technology people around it really don't care and are amazing people. But it's left us in this situation where we're like, okay, istio is a great service mesh and it's really feature rich and it's just developing so fast. But the scary thing is that it's not open sourced like most of the other tools that we're building our stacks around these days. And then the open source ones that are in the CNCF, like linkerd is one of them, don't quite have the adoption of istio. So I feel like, and it's one of the reasons I haven't written a service mesh book or created a service mesh course yet, is because, like, just for instance, for a video course, if I was to create a 4, maybe 5-hour course on service mesh, it would take me 6 months to build. A full 6 months where I almost can't do anything else. And if I do it on istio and then the market stops using istio and use linkerd or something else instead, I've wasted 6 months. Well, I haven't wasted it, but you know what I mean? So even me as a content creator, I'm like, there's too much uncertainty for me. Though I will say, right, I think if you go with anything like istio or linkerd, console, some of the others, I think at the moment, they've all got strong roadmaps. I think they've all got bright futures. I don't think, like, unless you choose something really quirky that maybe we've never heard of, I don't think you're gonna have made a huge mistake.
Yes.
I'm not sure that I really helped there.
No, definitely. It's a really interesting session. It's going to be a very exciting session for me, and I hope everybody who are listening to us. So it's a kind of a things that we, at the end of the day, at the end user like me and you, Nigel, we are actually feature rich with the service mesh right now, because before that, it's linkerd doesn't support this kind of, but they are fighting and going to be at edge and toward the edge and competing with each other. So at the end of the end user and everybody happening to us. So before I let you go, there's one question that people are asking me, that you are running a cloud native Islamabad community. Just define the term what cloud native is. So can you help me define this term, what cloud native is?
Yeah. So the definition of cloud native, according to Nigel Poulton, this is just my opinion, okay? When I talk about something as being cloud native, I think that it is, well, for starters, I will say it does not mean that it just works in the cloud, right? You can run cloud native applications on premises in your own data center if you want to. I would say cloud native is a set of cloud-like features that an application has to have. Self-healing, auto-scaling, rollouts and rollbacks, like zero downtime rollouts I'm talking about here. So I'd say those 4 things: self-healing, automatic scaling, zero downtime rollouts and rollbacks. If an application does that and it runs on Kubernetes, it's cloud native in my book.
Oh, it's a very good, it's a great definition. And for the last thing, that's what Cloud Native Computing Foundation is, what these roles are, because people are struggling to find, for the beginners, what Cloud Native is, what these are. Because as we said it earlier, there's Kubernetes is asking us to do a lot of stuff like container runtime, network interface, storage interface, monitoring and tooling and logging and tracing. So Kubernetes asks us to do that stuff for them, and they can do the high level stuff for managing the applications and container at scale. So can you introduce what Cloud Native Computing Foundation is, or what's their aims are?
Yeah, so just at a super high level, Cloud Native Computing Foundation is, it's like a group of tech companies that have come together to form a foundation that will say, right, we're building modern applications, right? But a modern application is a full stack. Like you've just said there, Saim, there's all these kinds of things, logging, tracing, the lot, right? And the Cloud Native Computing Foundation, or the CNCF, its role is to take open source projects that build this stack and to nurture them, or to build them from being small, tiny ideas and projects, help them become production grade tools. And Kubernetes has gone all the way through that and is a production grade tool. Plenty of other tools have gone through as well. If you go to the CNCF website, you'll see loads of graduated projects. But the idea is we're building on stacks. Anything that's open source and builds on that stack has the potential to come in and help to grow by the Cloud Native Computing Foundation. And they govern it as well and make sure that it really is open source and that the correct code of conducts are in place and all that kind of stuff as well.
So thanks, Atan. I think today I give you the some kind of a challenge to explain some buzzword without having diagrams and without using the diagram. And actually you do that tremendously. And I hope everybody listening to us and relatively new to Docker and Kubernetes, they had at the end of the day written how to know how Docker came into being, how Kubernetes came into being, what service meshes are, what Cloud Native Computing Foundation is, and many of the other stuff. I really appreciated your time. And I've been introduced to these terms like Docker, Kubernetes, and service mesh because of Nigel Poulton. Awesome book, awesome content on A Cloud Guru, Pluralsight, Udemy, and other side of things. So Nigel, interesting to know what your aims are in 2021.
Yeah, so I just released a new book already this year. So that's number one checked off. So I released a book called Quick Start Kubernetes, which is aimed at anybody that is brand new to the idea of containers and Kubernetes. But somebody that's already an IT expert in something else needs to get their head around it. Now, I think we already have a paperback edition available via Shroff Publishing in the Indian subcontinent. So that's my number one thing done. My other thing is, so I'll be updating my other Kubernetes book and my Docker Deep Dive book this year. And I want, and this is my big project for the year, which I haven't started on yet, is I want a book and a video course for the CKAD exam. That's like my big project for the year. So I've got my little one done, Quick Start Kubernetes book. I've got a couple of other books to update, but then a book and a video course for the CKAD certification. That's me.
Yes, I think Nigel's books are, to me, is the battle-tested and battle-proven books if you want to get into the Kubernetes. And I learned so much from you over this long time, and I've been following along you. And you introduce me every time I see you talking in KubeCon, Cloud Native Con, and DockerCon, ServiceMeshes. I get to introduce to the new buzzwords. And I think Nigel is a person, if you want to learn, if you want to hear about more buzzword in future. So I think I really appreciated and really ton of cool stuff that I'm learning today. And everybody who is listening to us, I think number one is to go to nigelpoulton.com and grab a Kubernetes Quick Start book, And then we go to some Kubernetes deep dive book is also for you, Docker deep dive also for you, and Nigel is everybody into the container ecosystem, like container networking, storage, runtime, everything. So today I give a task to Nigel to explain everything without using diagrams, and he did it tremendously. So thanks, Nigel, for for the session tonight, and I hope to see you in future as well as your other projects are came into being in the market. But tonight, really appreciated your time and hope we can see you again in future. And thanks again for the Ash Poulton who joined us and we are doing the next session for us. So if you're watching Ash Poulton, thank you very much for connecting with me.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.